Oh, hi there. It's Professor H here and getting ready for our next experiment in our Water Everywhere class. I hope you're enjoying it. I know a lot of people have been on the forum and there's been some really neat posts. And don't worry, we are going to tell you this week how the burglar got in, because I know we've got a lot of people asking if we're going to tell the answer, and I will tell the answer. But right now, I want to talk to you about flower power. That's right, or I should call it water flower power, because that's really what it is. Now, in the worksheets provided this week, you should have a template that when you cut it out will look something like this. And it's pretty simple. Now, you're welcome to color it or decorate it or do whatever, but make sure that you keep it as normal paper. Don't glue anything to it because you'll need it like this. And you just need regular old copy paper or multi-purpose inkjet paper. Nothing special. Don't use glossy paper. That doesn't work as well because it has a laminate coating on it that will prevent this from working. Because what we're going to do is this paper is going to be our flower. And so after you cut it out, you can just kind of fold the petals down so it looks like a regular true flower. And you're going to need a glass with some water in it, which I have here. And you can use a bottle of water, that's fine, or tap water. It really doesn't matter. You're not going to drink it. So it can be, whatever kind of water you want. And a bowl. I've got a clear bowl just to make it easier to see, but it doesn't have to be clear. And I'm going to pour my water in my bowl. Oops, a little bit of splash there. Make sure you ask mom or dad before you pour water on your table. Don't want you making a mess. And what we're going to do is we're going to talk about capillary action. Capillaries, that's a long word. What it means is it's tiny little tubes inside of something. You've got capillaries inside of you. What your capillaries do is they move blood from your veins and your arteries back and forth. And actually they move it from the arteries to the veins after they've released their oxygen to the different parts of your body. In a flower, what it does is it's what allows the flower to get water all the way out to the ends of the leaves so that the little parts of the flower can get water, because that's how they drink. They don't have a mouth like you or I. They have to drink through their leaves. And what the capillary action does is the water is pulled through those little tiny tubes, and when it gets to the ends, the weight of the water is actually going to open the flower up. So what we're going to see is this flower, when I put it in the water, is going to open up. Now I want to make sure you can see it real good, so I'm going to pause for just a second so I can get the camera in a little closer. Okay, so I'm going to put my little flower in my little bowl of water, and you want to be real careful because you want it to float, you don't want it to sink. And almost immediately it starts to open. And there it goes. And what's happening is all that water is being slurped right up in that piece of paper just like a real flower. Now here my flower is. It's pretty wet now. And I'm just going to kind of lay here so it can dry. But it'll just go in the trash. I just don't want it to get so sopping wet that it makes a mess on my table. And what we've learned now is we've learned about capillary action, which again are little tiny tubes that force water to go down the tubes and get to the other end. Or in our body they force blood, but in the flower they force water. And some of the things that you can do with this experiment besides watch it, which is really neat, and I am not going to do this right now, but you're welcome to do this at home, is maybe experiment with different size of paper. We give you one template, but you're welcome to cut out flowers whatever shape, size you want. Maybe make one bigger, maybe make one more of a circle. Just remember, you do need to have some type of break between the stems in order to fold it up. It's not so much necessary for the capillaries, it's necessary so that you can actually fold it. So make sure you remember that. Also, maybe time your flower. The different shapes take longer, or maybe they're quicker. And these will let you know some of the different ways why flowers have some of the different shaped petals they do. Now they don't just have them for the flower. The flowers don't just have those different shapes. For capillary action, they also have them so that they can pick up different types of sunlight, so they can pick up different types of pollen not pick up the pollen, but be pollinated by the bees and the different insects that pollinate flowers. So there's a lot of things going on, but one of the reasons they're designed the way they are is so that they can have good capillary action to get opened up. And that's part of the science of learning about water and the science of learning about flowers. So feel free to experiment, feel free to make different size shapes, time yourself, whoops, there it went. Time your flower opening and closing, time how long it takes for it to get totally sopping wet if you want to, and maybe try different types of paper. If you've got copy paper, and maybe you've got construction paper, or maybe you have some different types of paper, notebook paper will work. Try different types and see which ones are quicker or slower or whatever, and just have fun with it. And that's the end of this week's experiment.